Section 11.1, Measures of Center and Variation. We are moving into the statistics part of this Algebra 1 course, and so we're going to see things that look a lot different than anything else we've done this year. We're going to start by talking about measures of center. Those are measures that represent the center or typical value of a data set. And there are three terms here, the three M's, that you've probably used before and probably are familiar with. We have mean, median, and mode. So we can talk about each of these and how to find them. First, we have the mean, or average. The mean is calculated by finding the sum of the data divided by the number of data values. Another way of saying this is add up all the numbers and divide by the number of pieces that there are. This is often written as an X with a bar on top, read as X bar. And this is just a way to represent it. We are adding up all the different values from a data set. These represent all the different numbers. This ... means that you would continue until you cover all of them. And then you divide by the number that there is. And that's how you calculate the mean, or the average. Up next, we have the median, which is found by determining the middle number when the values are written in numerical order. When a data set has an even number of values, you won't be able to find the exact middle number, so you'll find the median by determining the mean of the two middle values. So you'll go to the middle and find the two values, add them up, and divide by 2. So the median is just the number that's right in the middle. With an odd number, it's pretty easy to find. With an even number of data points, it's just one extra step. And finally, we have the mode, which is the value or values that occur most often. You can remember that mode starts with MO, which should be corresponding to most often. And there may be one mode, no mode, or more than one mode. If everything appears the same number of times, we wouldn't say that everything is the mode, we'd just say that there's no mode. But there can be multiple modes depending on the data. So these are the three measures of center, and let's try to calculate these based on some real-life numbers. So this is Stephen Curry. He's a point guard for the Golden State Warriors, and the numbers represent the number of points scored in each of the 15 games that he played of the 2015 Western Conference playoffs. And I'd like to use that data to determine the mean, median, and mode of his scoring. Now, in order to do this, at least in order to do the median, and what would help with the mode would be to put this data in a convenient order. We'd like to write it in numerical order going from least to greatest. So before we do anything else, let's start with that. So, written in increasing numerical order, we can see that Steph Curry had games where he scored 18, 19, 22 twice, 23 twice, 26, 32, 33 twice, 34 twice, 39, and 40 twice. That many points in his 15 games so far in the playoffs this year. So now we can figure out these three measures of center. We'll start off with the one that involves the most calculation, which would be the mean. Now remember that to determine the mean, which is also known as X bar, we would have to figure out the total number of points and divide that by the total number of games, which is the number of data points. So using a calculator or doing it out by hand, we can figure out the sum of all the points that Steph Curry has scored and divide it by the 15 games that he's played. And when we do that, we find out that he scored 438 total points in 15 games, which gives him a mean of 29.2 points per game. Now, in this case, the division terminates at 29.2, and in many cases, it will be something that we'd have to round, and you'd look for the directions or just a reasonable answer in that case. So you could round this to about 29 points per game, but 29.2 is the exact mean. All right, let's next take a look at median. The median, which is the middle number of the data set written in numerical order, is pretty easy to find here because we have 15 data points, which is an odd number, so we're just going to search for the middle number. So from left and right, we're both going to come in same number of times. So 18 and 40 is matching up, 19 and 40, 22 and 39, 22 and 34, 23 and 34, 23 and 33, 26 and 33, which leaves me with a median right in the middle of 32. And fortunately, I was able to just figure that out pretty easily. And so now we have our second measure of center. And finally, let's discuss the mode. The mode is just whichever data points appear most often, if there's anything that appears more than anything else. And there are a couple of examples here, more than a couple. You'll notice that there are 222s, 223s, 233s, 234s, and 240s. Everything else shows up once. So as a matter of fact, these are all different modes for our Stephen Curry's scoring. So this is one scenario in which we actually have 5 modes, which is probably pretty uncommon, but that's what the data tells us here. These 5 values show up twice each in the 15 games, and so that's the mode of the data. So there we have the 3 measures of center of Stephen Curry's points scored in the 2015 Western Conference playoffs. Connected to the measures of center are the measures of variation, and these are measures that describe the spread or distribution of a data set. And there are 2 of these that we're going to discuss today: range and standard deviation. Range is pretty quick. In order to determine range, we only need to find the difference of the greatest value and the least value. We take the largest number of the data set and subtract the smallest number of the data set from that. So that's how you calculate range. The standard deviation is a little bit trickier, but it comes with a nice formula. So, what's going on here with this somewhat intimidating looking formula? We have this symbol here, which is a Greek letter sigma, and we have a big radical, big square root here, and it looks like we're doing something similar to mean because we're adding a bunch of things up and then dividing by the number of things that there are. And we actually see the x bar, which is the mean itself. And so let's take a look at what's happening here. The first thing that we would need to do is we'd need to calculate the mean. After we've calculated the mean, we're going to subtract the mean from each and every data point that we have. We're going to end up with some positive numbers, some negative numbers, just to figure out how far away from the mean each value is. And what that's called is the deviation. After we do this, we're now going to take each of those deviations, which are all of these subtractions, and square them, raise each one to the second power. This will eliminate any negatives. We'll only be dealing with positive or 0 values. After we square each deviation, we're now going to add them all up and divide by the number of deviations. What that is that's actually finding the mean of the squared deviations, and we call that variance. And then finally, once we've done all of that, we're going to take the square root of our result. Now, the good news is we're not going to be relying on simplest radical form here. For anything like this, it's calculator work, so we're going to be able to just use a calculator, find an approximate answer, or maybe an exact answer if we're really lucky, but we don't need to work through simplest radical form here. And there you have your 5 steps to determining the standard deviation, and we're going to see if we can apply these steps now and then see what the point of them is based on the data that we have. So let's give it a shot. Alright, so let's take a look at Steph Curry's shooting or scoring data once again and see if we can figure out the range and standard deviation. The range is what we'll start with because that's pretty quick. The range of Steph Curry's scoring is just the highest value minus the lowest value. So I've just taken the data that we had organized in order to determine the median. And to figure out the range, we just do 40 minus 18, which gives us a range of 22 points. So the difference between his highest scoring game and his lowest scoring game is 22 points, which is a pretty decent spread. I mean, 40 points is pretty high and 18 points is low compared to what he does on a typical game, but that's about what it is. Now the 22 there is not really connected to the measures of center. It just tells us how big of a spread that is. Standard deviation, a little bit more involved. So let's revisit those 5 steps and see what we can do. The use of a table might make this a lot easier to understand. What I'm going to start with is I'm going to put all of my data values in for my list from 18 up through 40. If I have repetitions, I include them. You see I've got 222s, 223s, etc. In the second column, I list my mean, which I already calculated to be 29.2. We found that previously. Then I'm going to subtract the mean from each data value. Now this is something you can use a calculator or a spreadsheet for. And you'll notice that I start with large negative deviations. They become smaller and eventually become positive deviations, getting larger. That's because the 18 is 11.2 points below the mean, and 26 is only 3.2 points below the mean. Once we get to the 32-point game, everything else ends up becoming above the mean, culminating in 40-point games that are 10.8 points above the mean. So I take each of my deviations and then square it using a calculator. Negative 11.2 squared goes up to 125.44. And you'll notice here what's happening is I get to be a smaller deviation, positive or negative. My squared deviation is going to be a lot smaller before it grows up, getting over 116 for the 40-point games. So those are the first couple of steps to find the standard deviation. Now I need to average all of these squared deviations in order to find what we call the variance. To find that average, or the mean, I add up all of the squared deviations and then divide by 15. So using a calculator, we are able to determine that the sum of the squared deviations is 832.4. Divided by the 15 values there, we get about 55.49, or approximately 55 1/2. So that's the variance. And now to find the standard deviation, my final step just involves finding the square root of that number. And when I do that, the square root of 54.49 is about 7.38. And so the standard deviation of Steph Curry's scoring in the Western Conference Playoffs 2015 is 7.38. Now, what that means is that a typical scoring game for Steph Curry will differ from the mean by about 7.4 points. So keeping in mind that the mean was 29.2 points per game, we would expect that for a typical game, Steph Curry would probably score within 7.4 points of that, so maybe as high as 36 points and as low as 22 points. And I think you can see from the data here that most of the games are within that range. And so that's how you would determine standard deviation. It's a little complicated, but if you just take your time and use a calculator and use a table to help you stay organized, you should be in good shape. Now, the last thing that we have to talk about today are the outliers. And outliers are just data values that are much greater than or much less than the other values in a data set. We're going to get into the formal definition of an outlier, how to calculate if something is truly an outlier later on in this unit. But for now, we're just going to use our good judgment and say that something seems way out of place because it's way too high or way too low. An example of this would be, suppose that in Game 1 of the NBA Finals, Steph matches the other Warrior great, Wilt Chamberlain's feat of scoring 100 points in a game. Of course, Chamberlain did this when they were the Philadelphia Warriors, never been done by anyone else in an NBA game. But let's say that Steph Curry gets 100 points in Game 1 of the NBA Finals. Clearly, that number is so much larger than all of his other points scored in the game that would be an outlier. Well, what effects does the outlier have on the other measures we've discussed today? What I'd like you to do is pause the video at this time. Use 100 points as a 16th data point and try to calculate the mean, median, mode, range, and standard deviation of Steph Curry's scoring. What we're going to do is then come back and look at the actual effects that they've had on each of these measures. So pause the video, do those calculations, and then come back to check your work. All right, let's see how you did. All right, how did it go? You can see that the mean jumps from 29.2 up to 33.625, which, considering that we're talking about points scored in a basketball game, an increase of about 4.5 points per game is pretty substantial over a 16-game sample size. So that's a pretty big gain because of this large output in the 16th game. The median has only a small change, and that typically will be the case when there is an outlier. The median is only going to shift over one spot to the left or to the right. And in this case, because it goes from an odd number to an even number, we actually just would be averaging 32 with 33. It's the mean of the two middle numbers, since there's an even number of data points. And so an outlier doesn't typically affect the median all that much. Similarly, it often won't affect the mode. If it's just one outlier, it's not appearing multiple times, and the mode is unchanged. It's still the same 5 values that you had before. The range is extremely affected, which is probably something that you would have expected. We go from a range of 22, which is not that big, to a range of 82. The difference between Steph Curry's highest and lowest scoring output is 82 points. That's a really big gap, and it just means that the data is really spread out, so it's something to consider there. And our standard deviation actually has a really big increase too. It goes from 7.38 to about 18.59. This means that in a typical game, we would expect Curry to score within 18.5 points or so of the mean, which has jumped up to 33.6. So roughly speaking, we would think that in a typical game, he'd score anywhere from about 15 points or all the way up to 52 points, which is a really huge range, kind of hard to predict in there. And if you look at the data that we originally had, that most of the data will fall into there, but most of it falls into a much more compact set. So oftentimes when we're going to be calculating measures of center, we will throw away an outlier, and that way it will make our measures a little bit more representative of the data. And there you go. That's section 11.1. I hope this example makes sense, and hopefully now you feel confident going forward.